Okay, so here are the answers to the homework. Let's just go ahead and disregard the answer to number one. I forgot to make the change on your worksheet because I realized it really wouldn't factor. If you tried to factor it from yours, I think it ended up coming like positive or negative square root of 3. Okay, but go ahead and check your answers. And if you have questions, you can have volunteers or have an answer key provided so we can address your questions. Alrighty, so let's go ahead and take a look at the 3.1 Part 2 notes. Today we're going to start to look at analyzing our graphs a little bit more of our quadratic functions. So some terms will be new, some will be review. So first thing is looking to find our x-intercepts. Either we can use our equation or the graph. Sometimes you can't always see them perfectly on the graph or it doesn't cross neatly. So then we have to figure out how we can find the x-intercepts, and that's what we pretty much focused on last class. We can factor, we can use our quadratic formula, or we could use our calculator. Okay, so let's go ahead and find our x-intercept because it doesn't look like it's crossing nicely. Not sure if this one will really factor nicely, so let's go ahead either and use our calculator or the quadratic. I'm going to go ahead and do the quadratic. So it's negative b plus or minus the square root of our b squared, so it's squared minus 4 times our a, which is negative 3, times our c, which is positive 1, all over 2 times our a value. Okay, so that's going to give us negative 6 plus minus. And when we simplify underneath the radical, gives us 36 plus 12, which is 48 over a negative 6. Okay, we can simplify the square root of 48. It breaks apart into the square root of 16 times the square root of 3. Okay, we can take the square root of 16 to be 4. We can't take the square root of 3. Okay, so that's our x-intercept. So probably you might need to punch that into your calculator to kind of get a decimal equivalent. So it comes out as, and I'm going to write it up here under x-intercept, a negative 0.15 and a positive 2.15. Oops. Okay, so those are x-intercepts. Y-intercepts, it's kind of easy to determine from our equation. Because remember, going back when we worked with our x and y intercepts in the last chapter, I think, we just plug zeros in for the x's. So pretty much your y-intercept is always going to be your constant. So when I plug in the zeros, basically it kind of cancels out those first two terms. So our y-intercept would just be a positive 1. Okay, to find our vertex. Okay, remember that's kind of the turning point of our graph. We do have a little formula that we can use. Okay, it looks a little confusing, but to find the x-coordinate of the vertex, it's negative b over 2a. And then to find the y-coordinate of the vertex, you take that x answer that you just found and plug it into the equation and solve for y. So let's take a look over here. So this was our x-intercepts here that we found. Okay, let's do our vertex. Okay, so first it's negative b over 2a. And so our b value was 6. So negative 6 over our 2 times a, so 2 times negative 3. Gives us 6 over negative 6, which reduces to a positive 1. That's going to be the x-coordinate of our vertex. Okay, what we need to find next is the y-coordinate. So we're going to take the answer of 1 and we're going to plug it in for the x's in our function. Okay, so it's going to be negative 3 times 1 squared. Oops, that looks kind of bad. Plus 6 times 1 plus 1. Okay, so 1 squared is 1 times negative 3 is negative 3 plus 6 plus 1. So it gives us 3 plus 1 is 4. So that gives us the y coordinate of our vertex. Okay, so our vertex would be at the order pair 1, 4. Okay, and finding the min and max, we're not even identifying, we're just determining which one we have. And remember, a min occurs when it goes in a downwards direction and turns up. A max occurs when it goes up and turns down. So in looking at a graph here, what we have is a max. Okay, domain. Okay, it's pretty much always going to be all reals, because when you have either the arrows pointing up or down, they're still getting wider left and right. So our domain is always all reals. Okay, and finding the range, it's going to be 1 or 2 answers. Okay, remember, range is always low to high. So if it's a U-shaped graph, you find that lowest value on the y-axis, and you'll list that number, and then it goes up to positive infinity. If both arrows are pointing down, it's negative infinity until the highest point. So if we eyeball our graph, the highest point of our graph, okay, is pretty much going to be the y coordinate. One second, lost my train of thought. Okay, so if I find the highest point of my graph, okay, it's pretty much going to be the y coordinate of our vertex. Okay, so since the arrows are pointing down, it's continuing forever to negative infinity. Okay, and then the highest it goes up to is a positive 4. Okay, and the y value should always match the y value of your vertex. Okay, the ending behavior, you can either eyeball your graph, or if your A is positive, both arrows are going to point up. If the A is negative, both arrows are going to point down. And since our A was a negative 3, our arrows are going to be pointing down. So it's our ending behavior. Okay, and then the last thing are increasing and decreasing. This is what you did in the last chapter. Remember, we put in interval notation, and think Patty pre-cal. Where are we on the x-axis when it starts to go in an upwards motion or downwards motion? So if we look back at our graph, as she's coming across from the left, our graph is going in an upwards motion till this point. But where is she on the x-axis? She's at a positive 1. Okay, so we go down to the bottom. So it's increasing from negative infinity to positive 1. Remember, we always use parentheses, so that's our increasing. Decreasing at that same point of 1, it starts to turn and go in a downwards motion, and as Patty continues forever in the positive x direction, it's going to continue in that downwards motion, so then it go on to positive infinity. Now, the numbers that are increasing and decreasing should always match the x coordinate of our vertex. Okay, so let's take a look at another graph together here. Okay, so in finding our x-intercepts, this one looks like it's probably pretty easy to factor. If we factor the x squared minus 4, it'll factor into x plus 2, x minus 2. And if we set each one equal to 0 and solve, we get our x-intercept to be negative 2 and a positive 2. Okay, y-intercept, if I plug 0 in for this x squared term, I'm just left with the constant negative 4. Okay, and then next we need to find our vertex, and yes, we can eyeball it pretty nicely from our graph, but let's just go ahead and kind of practice calculating it. Since our vertex, okay, remember it's negative b over 2 times our a. Well, there's no x value, so it means our b value is 0 over 2 times our a value, so 0 divided by anything is 0. So that's going to give me the x coordinate of my vertex. Then to find the y coordinate, I plug 0, my answer of 0, in for the x in that equation, and solve. We get an answer of negative 4. Okay, then we're just determining, does this have a min or a max? Since it's going in a downwards direction and turning up, we should have a min. The domain is always all reals. Okay, and then in doing our range, okay, since my arrows are pointing up, and we do low to high, I find the lowest point of my graph, which we said should always match up with the y coordinate of your vertex. So my lowest point is at -4, and then it continues forever in the positive direction. Okay. My ending behavior, we can either eyeball it from the graph, or the a value is a +1. So the ending behavior means both of our arrows should be pointing up. Okay, and then lastly, to do our increasing and decreasing. Okay, as we're reading from left to right, our graph is going in a downwards motion or decreasing motion. So let's go ahead and do that one first. So as we're coming from the negative direction, my graph is going in a downwards direction. And then once we get to this point here, which actually at 0 on the x-axis, that's when it starts to make the turn to go in increasing motion. So it's decreasing from -infinity to 0, and that's increasing from 0 to +infinity. And remember, we said the numbers, not the infinity symbols, we have two numbers that are increasing and decreasing. They should be the same, and they should always match the x coordinate of our vertex. Okay, so what I'd like for you to do is to kind of, let's work through one last one here together, and then we'll have you work through a couple with the partner. Okay, so the last part here is, again, we're going to try and find our x-intercepts. And again, we can factor, so we can kind of do the magic question. What multiplies to -6 and adds to a +1 would be 3 and a -2. Okay, my x-intercepts would be -3 and +2. My y-intercept, remember we plug zeros in for the x's, and it always turns out to be the constant. So it's a -6. Now we need to find our vertex. Okay, let's see if we can squeeze the work in here. So in finding the vertex, okay, it's -b over 2 times our a. Okay, so exists as -1/2. That's the x coordinate of our vertex. Okay, and then now we need to find the y coordinate. So we're going to plug -1/2 in for both the x's. Okay, so when I square the 1/2, I square the numerator, square the denominator. Oops, and that's a -6. Okay, so you either can find common denominators for everything, or you can punch it into your calculator. So if we find common denominators, it's going to be 4. I already have there. This one I multiply top and bottom by 2. And then to get from 6/1 to a denominator 4, I multiply top and bottom by 4. So now when I do basically my subtraction going across, it gives me -25/4, which if we change that to like a decimal, it's going to be -6.25 or 6 and a 4, -6 and 1/4. Whew, okay, so now we want to graph, okay? All we need to have in order to graph is basically what our x-intercepts are and our vertex. So if I go to plot my x-intercepts, I had one at -3 and one at +2. 1, 2, 3, and +2. And we can plot in our y-intercept if we want to. 1, 2, 3, 4, 5, 6. Okay, and then my vertex is at a -1/2 and a -6.25. So it's kind of right down there. So now then I'm just going to connect. Oops, I didn't do a very good job there. But I can connect it and make a sketch of my graph. And if we take the one that I took off the calculator, we can see it kind of matches. My graph doesn't look quite as neat. Okay, so now from here we can answer all of our other questions. Should we have a min or a max? We should have a min. Our domain, we said, is always all reals. My range is low to high. So remember, we always use the y coordinate of the vertex. Okay, and then it continues on forever to +infinity. My ending behavior, a value is positive, or we can see the arrows point up. And I'm almost out of time. Increasing and decreasing. Decreasing is kind of going first, because as I'm coming from the left, it's going in a downward motion. So it's -infinity until the x coordinate of my vertex, that's where it turns. And then increasing is